Are you struggling to figure out the right balance of unit tests, integration tests, and end-to-end tests in your PHP projects? Look no further. Antonello will convince you that it's no longer worth it. This talk will bring some clarity on the different types of tests. This talk will leave you with less confusion about the benefits and limitations of each test type and how to use them to improve the quality of their software effectively. Antonello Di Polito, a software engineer and agile practitioner, will present the topic. We are all ears.
That was easy. Okay, thank you for the beautiful introduction. I hope I can really keep the promise and shape up your testing strategy. So you can already understand that we are not talking about a simple, a single test that we are writing, but in a holistic way, we're looking at our whole test suite and our whole test strategy, because we need a strategy. And shape up, so we probably are going to talk about shapes, maybe, maybe not. Also here, I can keep the promise, so let's see how it goes. Well, for sure, we are talking about automated test suite, right? Because, well, that's what we want to shape. That's why we want to have a strategy. So an automated test suite is obviously a collection of test cases and scenarios that we can use to verify the correctness of our software system. So a software system doesn't really, it's not about just writing it, but changing it, evolving it. And every time we change our software, then we want to verify that it's still correct, that there's no regressions, and still does what it's supposed to do. That's why we have automated testing. So again, I talked about strategy. I will talk about design and possibly shapes. So it's a complex matter, right? There's lots of designing choices to be made. It's not just let's write a test that tests this thing, but you have to always think in a holistic way. And well, we're going to see what kind of design choices, what are the tools that we can use to discuss it with our team members, with our colleagues, for example. I am Antonello. I'm originally from Rome, Italy, as you can probably tell from my accent, I don't know. And I moved to the Netherlands 5 years ago, and I'm working for a company called Molly. We are a payment processor, so we process payment on behalf of merchants that sell stuff online, so things and services. We operate also in Poland, so you might have seen it in your bank statements or so. So we obviously move money, not our money, but merchants' money. So we are in quite a critical and regulated industry. So you can imagine that for me and for us as a company, having an automated test suite that does what it's supposed to do, it's quite important. So I personally, I want to pay a lot of attention to it. But let's start from the why, right? So why testing? Well, it's not really a choice, to be honest, because someone is always testing your software. Either it's you, maybe manually, or maybe with some automated tests, and then you use maybe an external system to check your code. We can use PHPStan, we can use a static analysis tool. So this is also that is also a form of testing. So you can have systems testing for you, or it's your end users at the end. If you don't test yourself, if you don't use automated systems to test your code, then it's going to be your user's job to test your code. And sometimes it might be good, sometimes it might be not. But also in terms of feedback loops. So let's say that we are here on the left side. I'm here on the left side, actually. The fastest feedback loop is obviously the test automation, the automated tests. Because you can run it on a CI machine, for example. You can run them locally if you're lucky enough, if your machine is powerful enough. So it's very fast feedback while you're developing your software, even obviously before you ship it. Then there's manual tests. when you finish your the implementation of your feature, you might want to manually test it yourself as a software engineer, as a software developer, or you might have, I don't know, for example, QA engineers or test engineers in the team. So you deploy in a specific environment your feature, and then you have manual tests, but you can already understand that is already a slower feedback loop because you need to deploy and then you need to wait for the feedback from yourself manually testing the stuff or from a colleague. And then obviously the biggest and slowest feedback loop is going to be your end users. So you might have monitoring in place, or you might have just people calling you and complaining that your software doesn't work. So that's also feedback. But it's very slow and it's very expensive, I would say. Pulse check. So I would ask, how many of you in your companies, in your projects, rely on automated test as a primary source of like testing your software? Quite a few. Then I suppose the rest rely on manual testing. Who relies on manual testing? Okay. And who relies on end users testing? Okay, yeah. Wow, very honest, very honest feedback. Okay, that's okay, that might be also okay, right? So it depends on how complex your application is, what kind of delivery approach you have. But for example, I found myself multiple times in continuous delivery, and I kind of try to push for it, a continuous delivery kind of environment. And so very fast iterations, deploying to production, so in the face of the end users multiple times per day. And then in that kind of situation, then you want the feedback loop on the correctness of your system to be as fast as possible, inevitably. So starting from this, you're easy to understand that you need a good automated test suite. But what exactly is a good automated test suite? Well, there's a lot of vagueness in this industry, I would say, but also because it depends a lot on the kind of application you have, and again, on the kind of delivery approach that you have. And but I tried to find 4 important qualities for what I believe is a good test suite, and it should be fast. Well, we already touched the topic, so as fast as possible. If I can run it locally. The entire test suite for the entire software that I'm touching in a few seconds or maybe a couple of minutes in my local environment, that would be ideal. That would be my perfect world. But even if I have to push my branch and wait for 10 minutes, 5 minutes maybe, in the CI system to tell me that the software that I'm touching doesn't have many problems, that's also good. That's also fast enough. It should be stable in the sense that it shouldn't fail for weird reasons. Like it shouldn't fail if the behavior of my code didn't change, for example. It shouldn't have flaky tests. So it's a plague, I would say, in some test suite, because flaky tests are tests that fails for no good reason. So sometimes they fail, sometimes not. And that takes time to figure out why they fail. They don't give you a proper feedback, so that's not good. We want our test suite to be stable. We want it to be trustable, because we want to ship in production with the confidence that our test suite, automated test suite, gives us. So we want to trust the entire test suite to tell us, okay, your software is correct, doesn't have bugs, or I'm fairly sure that doesn't have bugs, so you can ship to production. And in that sense, I have another talk in the afternoon on how you can trust your test suite. So if you're interested, it's a big topic to explore. And then it should be also informative. When it fails, it should tell us enough information, or pretty much exactly what failed, and what I need to do to fix it, or where I need to check my code to fix it. For example, if you have a test that says this feature doesn't work, or I made this call and I got a 500 internal server error, it's not that informative, right? So we want a test to telling us, okay, this class, this method failed for this reason. So we go there, we fix it, the test is green, super fast feedback loop, a super informative test suite. Well, having said that, we basically, what we need to do is we need to design our test suite with the same care that we do with our production code. And it's not an easy job, obviously, but it's something that we overlook often. And one of the tools that we have to start discussing and designing, for example, our test suite with our teammates, for example, is test types. But it's not an easy tool to manage, because there's a lot of different test types. I mean, these are all the test types that I've heard in my career, and that's probably half of them, actually. And I still don't have a clue on exactly what are some of them, and I have a vague idea what can be some other of them. But then again, what I experience is that in every team, in every company, or even in different individuals in the same team developing the same system, they have a different definition for each one of those test type. So what do we do with that? Well, we probably need to focus on the qualities of each test type, and maybe define some metrics that we can use. And with those more precise tools, we can choose which kind of tests we want and which quantity we want them. There is an interesting book that I started reading recently, and it's called Software Engineering at Google, so a very self-explanatory kind of title. And there's a chapter, obviously, on testing, and I think Google has quite an advanced way of testing their systems. I mean, quite obviously, but it's not that obvious. And the practices that they have and the scale they're at, it's very interesting. So I think it's even free, so you can Google it and read it. And they basically try to to define their different test types with two metrics. The first one is the size, and it's basically so a small test for them in terms of size. It means that it's a test that runs in one process. It only needs one process to run. For example, we are in a PHP conference, so a PHP test that only needs the PHP to be available to run. A medium test is the one that runs in one machine. That is, it can be also involving a database or a message queue, for example, in the same machine. Or a large test is a test that runs on multiple machines. So it can be also involving calling, making HTTP calls and reaching over on the network, for example. So yeah, that's to test probably different large components of our application. They also identify tests by scope, which is the second metric, and a narrow test is a test that is exercising a small part of our code, and it can be a class, a method, or a function in a case of a functional language. I would consider myself a narrow test also a test that exercises a class with its collaborators, and so a bunch of classes interacting together. It's still a narrow test for me. A medium test is a test that also involves another component of the application, for example, a small number of components. For example, again here, a database can be also involved. And then there's a large test that is similar to a large test in terms of size. It's testing several different components of our application. This depends obviously a bit on the complexity of our application, but yeah, it can be also a test that, again, reaches out to other subsystems through the network and so on. If we want to plot these two metrics, this idea on a diagram, and start maybe defining our definition of unit integration and end-to-end test based on these two metrics, to start a discussion with our team members and with our teammates and make design decision on our test suite, then we can use this kind of approach. So obviously unit tests, it's something that in terms of scope and size is small. So it's a narrow test, testing few things, and it's a test that needs to run in one process, so it's reliable and fast. Then if we go to integration tests, it gets a bit vague, because yeah, they usually involve more parts of a system. You usually want to write an integration test using a database or a message queue or whatever, so a different system that you do not necessarily own. And then end-to-end tests are necessarily large in terms of both scope and size. We can add to this, to help our discussion, the qualities of this kind of tests in relation with size and scope. And in terms of scope, then we know for sure that the large scope test, they give us more confidence because they test a big part of our application and in interactions between different parts of our application. So it gives us a good confidence. But at the same time, there's less precise. They are less informative. When they fail, they might say, okay, adding a product to your system failed. Yeah, okay, but which part where it failed? And in this sense, it's less informative. On the other hand, obviously, if we go towards unit tests or smaller scoped tests, then they're going to be more precise. They're going to tell us this method failed for this reason. But they give us less confidence because, yeah, they make sure that a small part of our system probably is working correctly, but then it doesn't tell us the whole if the whole system is correct. Very similarly and intuitively, in terms of size, obviously small size tests are faster and more stable. They just need one process to run, few resources, so they're hard to be flaky. While if they are more on a large size, then they tend to be slower and obviously less stable. There's another metric that Google doesn't mention or well, mentioned, but not really highlights it, and is one that I like a lot, and that should be part of your formula in a way when you're choosing which kind of tests you want to write, and is that narrow tests, aka unit tests, we can call them, I don't know, but narrow tests. Let's stick to narrow. Can drive the design of your code. I'm not necessarily talking about TDD, so test-driven development, or design, which I prefer. But if you listen to your tests, your narrow tests closely, most probably your code will become more maintainable, more readable. The single responsibility principle will be happy with your code. When we write a broad test, it means that we are basically exercising a big part of our system. The ends of our tests are very far from each other. And in the middle, we can write the spaghetti code. We have the freedom to write all the spaghetti code that we want. And being Italian, I know stuff about spaghetti and spaghetti code also. While with a narrow test, if you're hungry for spaghetti, then you're not necessarily happy because the narrow test is gonna give you a bit more of a constraint of the design choices that you can do. And in that sense, it's gonna help you having a more readable code. So you have less freedom, and less freedom in this case when you're designing code is kinda a good thing. So that's a metric that it's a bit more vague, obviously. You cannot really measure, or you cannot really say one process to process in one machine. It's it's a bit more vague. You need to practice a bit to understand how to listen to the test and so on. But it's still something that you might want to practice. You might want to take it into consideration when choosing which kind of test you want to write. So now we should talk about shapes because it's in the title. So, but should we talk about shapes? Is that really what we want to focus on? Well, I promised a shape, so let's put a shape. So, this is like a slide that it's been in my talks for years now, in different talks. It's very famous. It's the test pyramid. Who never saw this shape before? Well, like a couple of people. Okay, that's nice. Because this is kind of famous. It's been there for a while. It's been introduced, I don't know, probably 20 years ago, I don't know. But it's basically telling us that you should have lots of unit tests, or you can call it narrow tests or small tests, a bunch of integration tests, so a bit less small, and then a few end-to-end tests. Here it's called also UI tests, if you have a UI, and a bunch of manual tests when needed. And it is basically in the shape of a pyramid because it's telling you that the higher you go on the pyramid, the most expensive these tests are. And here we can relate in terms of size, in terms of scope, they are larger in a way. And that is, it was kind of okay for a while. Then obviously, I mean, we are software engineers, so we challenge the status quo, and that's good. And then different kind of companies came up with different shapes, and they got really creative with shapes. This is a shape with static. Yeah, we listened to a couple of talks about this. Then this is a trophy. So static. Then you have a bunch of unit tests, lots of integration tests for some reason, and a few end-to-end tests. So this is to highlight that you don't need that much of a unit test or that many unit tests, but you need a lot of integration tests. This was talking about return of investment, which is a very good concept to start with for JavaScript applications. It's not necessarily wrong, but then obviously the creativity of the software industry never stops. And then Spotify, which is famous for this kind of like trying to make the revolution, which is very good. They went for full microservices kind of architecture. So smaller services, they probably talk to each other through the network. So you have this forest of microservices. And they say, well, your testing strategy should be, in this case, should be like an honeycomb. So you have a few implementation detail tests. I don't know what that means. But there's an article, so if you're curious, you can check. Again, lots of integration tests and a few integrated tests. I don't know, again, what that means. But the thing is, I could have read I actually read it, but I could have explored with you the nuances of this division. But is that really worth what an integration test is? The definition is blurry here. It depends a lot on what you mean. For example, for me, a test that tests multiple classes interacting together, for some people can be an integration test. For me, it's not. It's a narrow test. It's a unit test. So in microservices, you can use contract testing, for example, instead of actually writing a test that actually reaches on the network and calls the other service. You might test your code against a contract that you have between you and the other service. Is that an integration test? Maybe yes for Spotify. Maybe that's why they have a huge integration test kind of shape. But yeah, it's not the real focus that we should have, in my opinion, also in Justin Sir's opinion. It's nice to debate the percentages and the details of the unit test, integration test, end-to-end test that we want, but in the end, it's And it shouldn't be the focus. The focus should be on the qualities that we want from our tests, because writing tests is obviously expensive, so we need to make it effective, and we need to talk about clear boundaries. We need to talk about speed and reliability and trustability of the tests, not really a unit integration on end-to-end. You can define those things, but you should probably more defining them, as I told you a few slides ago, based on their qualities, on their characteristics. And you can use the scope, the size, you can use just these vague qualities that I came up with, but it's really, you need to think about the quality of your tests and then define which one you want for your specific case, for your specific application. That is, again, design your test suites with the same care that you do with your production code. I know it's expensive, but it has a return of investment if you do it properly. If you're I've been in Monolith that started with a lot of end-to-end and integration tests, and then this monolith became big. The test suite became big and at some point unbearable. It doesn't run on a single machine anymore. It takes a lot in a CI, so you need to scale vertically your CI system, and it's expensive. So think about this stuff. Think about the scalability of your test suite. Think as much as you think at the scalability of your code. Because testability is basically maintainability. Because if you have a fast and reliable test suite, your code, it means that your code is more maintainable because you can change it more frequently and with more confidence. And this gives you agility, which is can be a buzzword, but for me it means that I can iterate quickly and ship to production quickly and with confidence, and it means that I can change the direction of the product in the way I want. I can measure and change, measure and change, measure and change. And that is gonna probably give me product success, obviously, if I do the right product choices. And then quite literally, it's gonna mean profit. And so the next time someone is asking you, why should I put some effort in writing tests or even in designing my test suite, well, show them this slide. Or give them my Twitter handle. And dziękuję, or thank you for listening. I hope I didn't butcher the dziękuję. It's okay? Okay, perfect. What's sorry? Prego, I would say. Questions? We have some time, yes. Before lunch. 10 minutes, yeah, so. I want to throw this, so, okay, cool. Let's see. Okay, close enough.
Hi, if you don't have a test suite ready, any kind of test, from which part of the pyramid would you start, from the top or from the bottom, building your test suite, designing?
That's a very good question. It depends a bit on the approach that you want to have. For example, if you practice behavior-driven development, you might want to start from a broader test. So from the top of the pyramid, you write the test for all the feature, and then you start writing maybe the narrow test, the smaller test to start the implementation. And at some point they become green, and at some point also your end-to-end test, it will become green. Personally, I would even start with, it depends on the application or the practices, but I would even start with just writing my models with unit tests or narrow tests. And then when I finish my feature, I decide, okay, which part of this feature I want to test, and then I write a bigger integration test or end-to-end test at the end. Yeah, it depends. Other questions? Or you're ready for lunch already? Huh? Yeah? So the question is, should we test a single class separately, or we can test maybe a component? I usually try to test single classes, but with their interaction with other classes. For example, there's a school of thought regarding unit tests or narrow tests that I think is the London School of Testing. That is, you should mock everything else and you should focus only on the class that you're testing. There is another school that is the one that I usually follow, and is yeah, you should focus on your object, because if you're testing it, it's probably worth testing it. But then I use the right, the real collaborators, and then you end up testing a small component in the end. Yeah, so testing every single class can make refactors hard. Yes, but you should never test the implementation of the class. You should try to test the behavior. So, like, think about that class as a black box, or that component, that bunch of classes as a black box. So, if you want to refactor only the implementation of that class, the test doesn't fail. That helps. But yeah, one of the properties that should probably add is the tests should never get in the way of refactoring. So if you realize that writing tests that way is, I mean, it's a friction for your refactors, then you should probably change the way you test. Maybe you should write broader tests, or should write code in a different way. Then it depends on the case. But yeah, it's a good question to ask yourself when you're writing tests. Is it going to help me for refactoring or not? That's very good. Yeah. Yes?
What approach do you prefer in backend test to see data per test, or have a plain MySQL with all the data to speed up the test when you have a lot amount of tests?
So the question is, what can...
Big amount of tests.
Yeah, okay.
Yes. Thanks. What approach do you prefer when you have big amount of tests to seed the database per test?
Okay.
Or to have plain MySQL and seed it just once at the beginning of the test, speed it up?
Okay. Yeah, well, I generally try to not necessarily have a lot of tests that interact with the database. So what I will try to do is just testing my integration with the database. So for example, most of the time we have a repository, like we saw in the talk before. We would have a repository interface and then a doctrine repository, for example. Then in that sense, I use the real database, because maybe I want to check my interaction between the repository and the database. But then if I need to test, I don't know, a broader part of my application, I try to not use the real database, but maybe use a test double, a repository test double, that does the same thing as the real one, but just doesn't persist. So if I can write a lot of tests and still being fast, being stable, because they don't use the database. Okay. Yeah. Yes.
Oh. Okay. Let's imagine that you have application that integrate with some API, and you have two different ways. You can use that API from a third party, or you can do some mocks. Which way you prefer?
There's a third way, which is contract testing. So that is, you establish a contract, so an interface definition between of the other system, for example, and then you create a mock or a test double using that interface. You can create a test double manually, but then it goes out of sync because maybe your test double answers the calls in a way, but then the other system evolves and changes, and then you have this out of sync situation. Calling the real one, it's expensive, so you have to do it in very, very critical situation. Like if my application doesn't make sense without this service, then I might even call the real service every time and check if it works. But then it's expensive, it's unstable, so you need to use it very, how can I say, with pragmatism in that sense. I would prefer a test double in any case, either with contract testing better, or a test double that I customize myself, knowing that it can go out of sync, so paying attention there. We have 3 minutes, as far as I understood, so maybe another question, or? Yeah?
We have more integrational tests, or only unit, PHP unit?
I used PHPSpec and PHP unit even for unit tests, and behat also for integration tests or broader end-to-end tests, yeah. And it's good because you can use the Gherkin language and have it more a natural language kind of tests, which are really helpful for reading and maintaining them. So that's, yeah, behat, it's a good tool, yeah. Okay. Well, thank you very much. Have a nice lunch. Spaghetti, maybe.